Tree diagrams are great for trying to figure out what it says here, the number of possible outcomes, or the way that things can happen when more than one thing is going on at a time. If it's just one thing, like you're just flipping a coin or you're just rolling a die, then it's not a big deal. But when you start doing the two together, then it really increases the amount of time or things that can happen. So we're going to start with drawing this tree diagram when a coin is tossed. There are two outcomes. What are the outcomes when you flip a coin? Heads, tails, yeah. So we have heads or tails. Those are our two outcomes. And then a die is rolled. How many, or what are the outcomes there?
1 through 6.
1 through 6. So you could flip, get heads, and then you could get a 1, 2, 3, 4, 5, 6. So this is why it's called a tree diagram, because it has branches. So obviously we can abbreviate it. We'll write H instead of heads, T instead of tails. So this is showing us all the possible outcomes. Sample space. This is the thing it says to discuss down here. The sample space is a list of all the possible outcomes. So that would be heads and 1, heads and 2, heads and 3, so on. And then tails and 1. What? So that's the sample space, when you list all the things that could happen. So the sample space is all the things that could happen, and a sample point is just one of the possibilities. So like maybe H3 could be a sample point. And it could have been any of them. I just picked that one. So the whole thing is sample space. 1 is a sample point. And the basic counting principle, also called the BCP, is when you multiply the number of choices for each outcome together to equal the total number of choices. That's the BCP, or the basic counting principle. Now, if you count that list up there, the sample space, how many points are in the sample space?
12.
There are 12, that's right. It's just by counting all these up, there's a total of 12. if we do the basic counting principle, we don't have to list them all. Like, we have how many choices for flipping the coin? 2. We have 2 outcomes, heads or tails. And we multiply that times how many outcomes we have for rolling a die. 6. And 2 times 6, sure enough, is 12. So the question is, why would we ever list them? Well, sometimes you need to list them just to figure out how many possibilities you have for on top. It's for the top number, not necessarily the bottom number. Hey, we just started. And I'm recording it, so I'll post it too. Okay. Jot down, I've highlighted what's going to be important. You can jot down just that. We're going to answer those questions. You can wait and jot them down as we answer them. It's up to you. Okay, so just to kind of read through it, you have 2 marbles. They're going to be selected without replacement. So what that means is, like, you have a bag of marbles. You reach in, say you pull out a green one. Put it off to the side, and you don't put it back in before you reach in and pull out the next one. So whenever you pull out more than 1 marble at a time, or more than 1 marble, it's only 1 at a time. You're not going to ever do them at the same time. I would specifically say that if I meant for them both to be. Okay. So the bag contains 1 red, a green, a yellow, and a white. It says, use the basic counting principle to determine the number of points in the sample space. So we're going to be picking out 2 marbles, 1 at a time, without putting it back in. So when we first reach into the bag of marbles, how many marbles do we have to choose from? 4, because there's red, green, yellow, and white. Then we take out that 1 marble, put it off to the side, don't put it back in. Now how many marbles are left? 3. So you have 3 left to choose from. And the basic counting